Let's talk about graphing polynomial functions. Here's an example. I had a few questions on graphing the exact graph. So let's kind of go through review. The first thing you want to do, I like this worksheet that I found. It kind of helps you to kind of write out your information. It's kind of nice and neat and organized, probably way more organized than I am. So, all right, so here's my function. We'll look at number one. So notice, it's already factored. This n degree, that represents the degree of the polynomial. And that just means you count. So this first x plus 1 squared, that has a multiplicity of 2. So I'm adding that. So 2, x minus 2 has a multiplicity of 1. X minus 3 has a multiplicity of 1. So if I add those, I have my degree of the polynomial to be 4. Okay? The next one says leading coefficient. So this, notice there's no number in front of the function. There's no 5 or -3 or whatever. So this one has a positive leading coefficient. It's technically a 1. The one below it down here has a leading coefficient of -2. Okay? All right, let's go back to this first one. All right, over here. Next, in behavior. Since it's in degree of 4, if y'all remember, that means it's even. So if you have an even function, I know that my end behavior is going to be something like this. Something who cares here is going to be up, middle behavior, up. If it was odd, it would be up on this side, something down here, down. That's going to be odd. And if your leading coefficient is negative for either one of these, it just flips. So I'll do that in green. So if it's even and your leading coefficient was negative, it would be down. Something like this. And odd for the end behavior, it would be something like this. Okay? So green is negative and red is positive. Okay? For the end behavior. And again, this is just a review, kind of refresh your brain going back. All right. So now, if you look to the right, this is how you write it out in limit notation. This means limit of f of x as x goes to negative infinity. So that means as my function goes off, and I'm looking at the even one, as it goes to the left, notice it goes up. That means as it goes to the left, it's going to go up, so that's going to be positive infinity. That's the left side. And over here for the right side is the limit of f of x as x goes to positive infinity. It goes up as well. Okay? If it was odd, as I'm going positive, it goes up. As I'm going negative, it goes down. If it was even and negative, as I go positive, it goes down. As I go negative, it goes down. If it was odd and negative, as I go positive, it goes down. As I go negative, it goes up. Okay? That's all these different ones refer to. Okay? The first part, they're going to be the same for all of them. This means the top one up here just means as the limit of the function as it goes to the right. Let's put here big R. And the bottom one is the limit of the function as it goes to the left. So what's going on with the function? Okay? All right, x-intercept. X-intercept is where it crosses the x-axis. Or remember, the other name is going to be 0. Another name is root. Another name is solution. They all mean the same thing. Okay, so they ask for those questions. Excuse me. So, first thing I'm going to do is sketch it. So if I look at each multiplicity, let's first plot our points. Let's use green. So to plot my points, I have a -1. So I'm going to go to -1, put a dot. This is going to be my rough sketch. I'm going to go to 2, put a dot. I'm going to go to 3 and put a dot. This is my very rough sketch. I look at each multiplicity. If I have a multiplicity of, notice the -1 solution has a multiplicity that's even. If y'all remember, if you have an even multiplicity, so about them down here, but these are going to be multiplicities. Okay, that doesn't look like I spelled it right, but anyway, multiplicity, close enough. All right, so if I have an even multiplicity, remember it bounces. So it's gonna either look like this or like this. If I have an odd multiplicity, remember it slivers, goes down, slivers through. And if the multiplicity is just straight up 1, it just goes straight through. Okay? All right, so with that said, now I'm going to go over here for my rough sketch. I'm going to go to -1, and I'm going to bounce. And I know my end behavior is up, because it's even. So I'm going to do this and something like this. So I'm going to go down. I'm going to bounce at -1 and bounce. I don't know how high I'm going to go. I don't know. All right, notice this one at 2, it's a 1. So I'm going to go straight through. And I notice the 3 is also a 1, so I need to turn, come back up straight through, and that's my rough sketch, 100 points. All right, so now I want to find my exact values. Okay, so this is my rough sketch. So for my exact values, we'll draw that one over here. You want to find your in-between points so you can see how high your graph is going to go, okay? So I don't know what my y-axis is going to be until I graph it. So let's go and type this in the function, in the calculator. I think I have the graph somewhere. I think it's here. There's my function, okay? And this is the calculator you use in class. So, y'all remember there's a few ways to do this. I'm going to go here, and I like to find my y-intercept so I can be exact. So where it crosses the y-axis. So I can draw it better. So let's go back over here. And how do I find the y-intercept? Go second trace. Then I'm going to go value. I'm going to type in a 0. That's going to give my y-intercept. Bam. My y-intercept is 6. Okay? Let's go back over here. And let's draw a 6 on there. Let's do that. And let's just do black. So this is 0, 6. Okay? I need to know how high does it go here in this between these two numbers. So this is a -1, this is 2. So what's halfway between -1 and 2? Add them and divide by 2. 2 plus -1 is 1. 1 divided by 2 is actually a half, to be picky. So I want to find out this ordered pair, 1/2, something. So now I'm going to go here to my graph, second trace. Let's type in value. And I think I said a half, 0.5, bam. I go up to 8.4375. That's not very large at all. So 8.4, remember your numbers can get really large here. So this one is 8.4, okay? So now I need to find this turn at the bottom. How low does that go? So I have 1, 2, this is 2, and that's 3. So between 2 and 3 is going to be about 2.5. Okay, so I go down to my graph, I go second trace, I hit enter on value, and I type in 2.5. And I get -3.06, and I think I told y'all can just round those to whole numbers. So -3 is fine. I could have just put 8 here. So now this graph is pretty small. So I can just go 10 to -10. And notice you can see everything on your actual graphic calculator, so you probably could notice that. So I'm just going to count by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's good enough for the top. 1, 2, 3, 4, 5, 6, 7, 8. I think I need to go at least -8. No, I went too far. But that's fine. So now I need to find my exact points. How do I do that? Go second, trace. Let's find that max value, the top one. So I'm going to hit max. Now remember, I'm going to move my cursor a little bit to the left of that max. That's the max right about there. So I move it to a little bit to the left of it, hit enter. It's saying right bound, move it a little bit to the right, hit enter twice. Voila. So my exact maximum value is 0.68, comma 8.64. Okay. Let's write that down. See if I can put these both in the same screen at the same time. So we'll try. All right, there we go. Cool. All right, so let's write down 0.68. So let's make it 0.7, comma 8.64. So about here in between 8.64, 1, 2, 3, 4, 5, 6, 7, 8, and a little more. So maybe here. The main thing, I'm going to write that point, 0.7, comma 8.6. And this is my exact graph, okay? And now I need to find the minimum. The way you find the minimum, we'll go second trace. I didn't do it right. Second trace. I need to go minimum here. Move my cursor over a little bit to the left of that minimum value. Hit enter. A little bit to the right of that minimum value. Hit enter twice. Voila. So my value is, what's that? 2.6 comma negative 3.12. So 1, 2.6 in between, down 1, 2, 3, about right here. Good enough for me. So now that's going to be 2.6 comma negative 3.1. Whoa. I was too close to the edge. Okay. And now literally just draw what you have over here. Connect your dots. Oh, I almost forgot my my y-intercept. So I need to go up 1, 2, 3, 4, 5, 6 right here. Now you have a very accurate graph. So I'm going to still have the same x-intercepts or solutions. That doesn't change. Okay. So now I go up, come down, bounce, come back. Notice it kind of goes through here, continues, goes to the max value, come down, goes straight through, goes down to the minimum value, the local min, and then there you go. Okay, hope that helps on the exact graph and the approximate graph. So let's see, I think that's it for that. There's more examples on this page, but again, they're just the same type of problems here, same review. So it'd be a good idea to go through if you want to go through and practice any of these problems. So I'm going to put this in the email that I'm going to send in the announcement. So, all right, hope this helps.